of that particular product. So in cell G22, we would just put what? Yeah, sum that row. And we're kind of used to this when it comes to like meeting demand kind of stuff. We're pretty familiar with that, but do you want to spot check it? Sure, you should. You know, it didn't need any real absolute addresses, it's all relative and it's good. So we sum all of that because we're gonna want that to make sure that we get all of the product that we need. Okay. We're also going to see how much we get from any given supplier because we're going to compare it to sort of an effective upper bound that we'll understand better after we make some more steps into this. But I am going to sum this column of how much I get from a supplier, okay? So here I'm gonna sum up that column. No absolute addressing necessary, I'll just copy it across. Okay. So just bear with me for a minute on this one. There's more that we'll know about this upper bound later, but right now I'm just gonna put a number in here that would be really the maximum amount that you possibly could get from a supplier. So I'm gonna sum up this column. This seems weird, but really if you think about it, if I ordered everything I could from supplier one, that would be the maximum I possibly could get from them. And so I'm just gonna put that here. Okay, I'm gonna sum up L22 to L29 over here and make that my, we're gonna refer to later as an effective upper bound. Which of course would be the same for every supplier. So just copy it across, it's the same amount for every supplier. Okay. What is, we'll come back to that later. What is my purchase cost? How do I determine my purchase cost? Some product. My hands are really cold, I don't type well anyway, and I really can't when my fingers are about to freeze off in this room, but anyway. So some product of what?
The large red array.
Yeah, the large red array, because this is what's telling me what's coming from the suppliers, and then which other range? The costs. And that's why we had to calculate this. I mean, this is absolutely an important part of this model to come up with your purchase costs, and we weren't going to be able to get it if we didn't make that, grid, if we didn't make those calculations. And so that, some product of those two things, wherever we're buying products, we're buying them at a per unit price. So obviously that makes up our overall purchase cost. Okay, our administrative cost, and if you remember this, it's actually up here. It's $5,000 for each supplier that we use. What are we gonna put here? How do we calculate that administrative cost?
5,000 times the supplier chosen.
Right, so 5,000 times, and what are you doing with the supplier chosen? Summing that up, yeah, so summing up, I don't know what's gonna be ones, what's gonna be zeros, but in the end, Excel puts ones and zeros in there, and for every one that goes in there, every supplier that we choose, okay, we have to pay a $5,000 administrative fee for that. Okay. And then overall, our total cost is summing up the purchase cost and the administrative cost. Okay, and that's an important cell because that is the cell that we're using as our objective and solver. Okay, so everything's good. Everything's filled in where it's supposed to be, and we head on over to solver. Again, I kind of just mentioned it, but we want to minimize total costs, right? So B36. Our total cost cell, our B36 total cost cell is the one we want to minimize. And we want to do so by changing the changing cells are the light red cells that we always see on here, right? It's this binary range, which will be telling us which suppliers we choose and which ones we don't choose, as well as the range where Excel is telling us how much to purchase of any product from any supplier, okay? Okay, so those two red cells, the B18 to F18, and then B22 to F29, those are my changing cells that Excel is gonna fill in, okay, when I'm minimizing B36. And I start adding some constraints. Okay, I'm gonna be likely to try to remember to put first things in first so before I forget, and so I'm probably gonna put what in first? Yeah, I'm gonna go over here and say, those cells, B18 to F18, have to be binary. Okay, that's part of the problem, to set which ones we use and which ones we don't use. So B18 to F18, binary. And then I know I told you I will always let you know when you want to do this or not, but I am going to add a constraint that says all of what we, purchase from a supplier, all of those numbers, will be integer values. Okay, so I'm putting the integers in there. Okay, so I kind of just get those two out of the way first. There's binary range, there's the integer range. Now I kind of begin to work with some of the other constraints. What's another constraint?
The totals.
Make sure that you get all the product that you need so that the total needs to be, and I put an equal in there. Again, remember on this kind of thing, you could probably put a greater than or equal, wouldn't make any difference to this problem because it's a minimization. Is there any chance it's sending you more products that incur costs? No, it's not. So, we would just go ahead and put the equal in there. So G22 to 29 has to be equal to I22 to 29. Okay, let's make sure we get all the product that we need. And then, what else? Yeah, let's put this upper bound constraint in where it's B to F30 less than or equal to B to F32. So that kind of row 30 less than or equal to that row 32. There's a little easier to see, but there is another constraint. What's that other constraint?
The products have to be less than the 80%.
Right, it's that 80% rule thing that we specifically made this grid for, that we want to constrain this range by the numbers in this range, okay? So we want to make sure right here that what we get of any given product from any given supplier is less than or equal to the max value of units we could get of any given product from any given supplier. So that is the one where this range is being constrained by this range. And when I click OK, I have 5 constraints in there because one's the binary, one's the integer. Okay. Then I have the 3 constraints: get the product, stay within the bound, the upper bound, and then the max 80 grid that we had there. Okay, so everybody's in there? B36, minimize it, these changing cells. When I click solve, yeah. So are we a little bothered at the solution that just came out? Okay, so interestingly enough, we didn't choose any supplier and we used all 5 of them. Okay, we didn't choose them, but we used all 5 of them. And therefore, since we didn't choose them, we didn't have to pay an administrative cost. Well, that's helpful. Okay. Not realistic, because it's not how this problem worked. It's not how the situation in reality worked. But mathematically, it sure was nicer to not choose any of them, use them all, and not pay administrative fees. I mean, according to this solution, I really ought to have $25,000 more of administrative fees in here that aren't in here. So here's a problem. Why would Excel have wanted to put values in there? There's nothing in this model that makes it have to do that. There's nothing in there that's forcing it to do what we know you have to do, which is choose the supplier in order to use the supplier, okay? There's nothing in this model that's making you do that right now. And so therefore it's not, because mathematically that doesn't benefit you in any way. Why would you do it if you don't have to do it? Okay, so I mentioned something to you once, okay. Before I get to that part of it, see if anybody can just think of something that you could do to incorporate this into the model to make it where you have to
You
choose it.
can put the cost in a certain range, and in a sense you would say make cost from this to that, and then as a consequence, it'll choose a supplier relative to that.
No, it won't make it. It might make it choose some, but you don't know how they would actually link to the ones you do choose. I know what you're saying. It's like, well, obviously it can't be zero. Administrative costs can't be zero. It has to be, but it has to link together somehow to to the ones that you're using. The choosing them has to link together with the ones that you're using.
Would you make it total times the supplier chosen? So your
Would I
total-
make what total times
The
suppliers?
total product times the supplier chosen, because then it would have to put a supplier meet the requirement.
Okay, yes, you're on the right track. So when I told you that I was putting this in, that we talk about it later, this upper bound is what we refer to as an effective upper bound. Okay, because really, in the problem the way it is right now, think about this for a minute. Did that even make sense that we even had that in there? Because every number here was constrained by every number here. So this didn't even do anything. This, as we have it, it didn't do anything. Okay, it was absolutely unnecessary extra something because every number here was already being constrained by every number here. We need this in here as an effective bound, meaning there should only be a number in there if you chose to use the supplier. Because if you didn't choose to use that supplier, then your upper bound on that supplier is zero. Okay, if you don't choose to use them, then you don't get to use them, then your upper bound on them is zero. So therefore, when you go into this and you look at this number, and it was never really about that number, the number was really unimportant. On the finish file, at one point, you're gonna see that the number I did was adding all of these up. It just needs to be a big enough number it would accommodate everything, because it's not about the number, okay? It's about using this number to trigger if you can use them or if you can't use them. And so what do we do with that number? Multiply it by that, right there. And see, that immediately says, if you don't choose to use them, if there's a zero there, then your upper bound is zero. If you do choose to use them and you put a 1 up there, then you have an actual number here. So see what I'm doing there? That number, which was really not about the number, it was just about getting a number in there that was large enough to accommodate everything you might want. Okay, when it's multiplied by 0, your upper bound is 0, because if you don't choose that supplier, you can't use that supplier. Okay, so now what's happened? Excel is going to be forced to put some 1s up here. Excel has to put some 1s up here, or you don't have the ability to fill your demand of what you're trying to get. There's no option. It's going to have to put some 1s up there. And chances are it's not going to put 5 1s up there, because it's now going to go out of its way to be more efficient in the way it uses suppliers, as opposed to, because you're incurring a $5,000 cost for every one that you're using. And so we don't want to do that. But it is going to have to put something up there, because this doesn't work. Putting it up. My solver model was perfectly fine. There's nothing about this that needed to change. I just needed to fix that formula. And if you want to stick the word in front of it, effective upper bound, that's really what it is. It's not about the number itself. It's about the use of that number to be able to, make this model work. Okay? So when I go to solve this, now Excel has to put some 1s up here. Otherwise, it can't order from those suppliers. It can't fill what you need. And when it puts 1s up there, what does that do? You incur administrative costs. So no, you couldn't order all of this for $174,000. That wasn't possible for you to order it all for $174,000. your best you're gonna do is this 193. Does that make sense? Because that's what makes this binary model a binary model. Okay, it's the ones that we're working with. I mean, in some ways, you know, assignment problems use binary variables for the most part, and that's usually what they are. You're assigning or not assigning something. They don't have to, but they usually do. It's incorporated in a different way. It's incorporated in a way that triggers something to happen that your model wouldn't do by itself. So those binary variables have to be used in such a way because those binary variables factor into the administrative cost. And you have to get some way that you trigger it to have to use those. Okay, and that's how we do it. Okay, that's where we put that. So the overall what's happening makes sense.
So before we then multiplied the zeros and the ones with the upper bound, was this filled, or was it pre-filled? The upper bound.
Oh, okay, so the first time I put it in, I just put the sum, and every cell had the number 3423.2. Okay, so there was nothing to stop Excel from just, hey, I've got capacity I can use,
And
you know,
where did you get
and
it
just
from
do it.
the 3423.2?
Where did I get that number?
Like the summation of.
Is the summation of this.
Okay.
But the really important thing is it's really not about that number.
Of course.
I think in one of the solution, I think you're gonna see I added this number up. As long as it's a number that's big enough to accommodate anything you would wanna do, and I knew that that was big enough to accommodate anything we would wanna do, it's fine. I mean, it really isn't the exact number that made a difference. You can't have it be too small of a number, of course, you know, because it could constrain it unnecessarily, but it's it ties in. It's what makes the whole thing, you know, work the way it's supposed to. Any questions about it? So when you're doing it, you have to think through that. But we'll get to see it a little bit more because on the first modification to the model, it says, we've come up with a new company policy. And our new company policy is that if we're going to order from a supplier, we want to order at least 1,000 units from them. A little bit of a problem with this solution is we're not conforming to this new rule. Well, let's go put our new rule in. I'm gonna go up here and this is one of the cases where I will insert. I'm gonna put this new minimum rule in, which is essentially gonna be my lower bound, right? That's what I'm putting in, is this new rule that you have to, if you're going to order from it, you have to order at least 1,000. Carry that percent. See, this is what I'm gonna do. Okay. If you're gonna order, you at least have to order 1,000. All right. I now have to make that a part of this model. That's apparently an important new management policy constraint that we've determined we want to go with. Here's how I would modify the model. I like to sandwich numbers in between their lower and upper bounds. I think that it looks readable to other people. I think it's easier, so I would grab all of this stuff right here, all of that. I would cut it, I would move down 2 rows, and I would paste it back in. And my reasoning behind doing that is that now I can put my lower bound right here. So I took all of this, scooched it down 2 rows so that I could leave a place here because I wanted what I get from my supplier to be sandwiched in between my lower and upper bounds. Now, people can modify models differently. You know, everybody doesn't have to do it the way I do it. I just think it's very readable for the user. I know that I need to calculate now or somehow reference a lower bound here. Okay. So what am I putting? Make this smaller so we can see everything. Okay. To squeeze it down a lot, but what am I putting now into B31? A reference to this 1,000 up here, okay, a reference to the 1,000 because that's the lower bound. real quick, I'm gonna make that an absolute reference, cause I know I need to anyway, and then,
Times that
Yeah.
supplier chosen.
yeah, so I can't just make a reference to 1,000, copy this across and say, we have a lower bound of 1,000. No, you don't have a lower bound of 1,000 for everybody, you have a lower bound of 1,000 for people you use, okay? Because if you put 1,000 all the way across there, well, actually, you'd mess this problem up, because you're not even requesting 5,000 units of products, so that would be an issue, okay? But, so yes, you put the 1,000 in, because that is a real lower bound, but it still has to be used in a way that's incorporated into the model. So you do still have to put, multiply it by its binary variable. Because the rule, let me get this bigger. Is only there, the bound is only there if you're using that supplier. So again, let me get where I can see the binary range up here. You know, if you don't use them, of course you don't have 1,000 as the lower bound. But if you do use them, then you do have 1,000 as the lower bound. So I've modified the model to include this. I next have to do what?
We'll add the.
Add the constraint into the solver model. And so I add a new constraint that I didn't have before, and I say this lower bound has to be less than or equal to what we get from the supplier. So if you put them in the same place as I did, then that's B to F31 has to be less than or equal to B to F33. Your guess, what's gonna happen to this total cost?
Stay the same.
Yeah, could stay the same, probably won't. But you know it's not going down. It's likely it's going up, because you're looking at this and saying, I had a best cost solution already, and it didn't order 1,000 from supplier 2. It used 2, 4, and 5, but it didn't order 1,000 from supplier 2. Obviously, that was my best cost. Is there a chance that there's another way to do it and come out? Yes, there's a chance, but you're probably going up in cost here because you're forcing it to do something it didn't originally want to do. Okay, when I solve this, just real quick, do any of you have 194.048? Okay, so you've left, and I should go ahead and just do it too. In Solver, but I'm in this room and everything always just keeps going back to the way it was before. But under the options, if you made that optimality percent that we talked about, if you make it 0, like you guys said, yours were still on 0, so I'm gonna put mine on 0 too. It will get a more accurate solution, and it just keeps wanting to default back to the 1. And that's okay, that's okay. But if you have it on the 0 and it gets a little bit more accurate, you will get down to the 194.048. You're still using the same suppliers here, but it bumps you up because you have to be buying things at a little bit higher prices than you probably wanted to buy them in order to adhere to this rule you didn't have before. Okay, now our company just keeps adding more and more rules to us so that we, can learn Solver. But the next one is, well, if you're going to use supplier number 2, then you also have to use supplier number 1. Because right now, we're using 2 and we're not using 1. Don't know why we have these rules, but we do, and so now we've got to figure out how to make them constrain our model. So if you're gonna use 2, then you also have to use 1, which we're not doing right now. Well, what are the choices here? Okay, so it doesn't say anything about if you don't use 2. I mean, it's like we don't use 2, well, we don't really care, I guess. But if you use 2, you have to use 1. So this is out, this one's not okay. If you use them, you have to use 1. If you don't use them, doesn't matter. Now, go first to what you think might be the easiest thing to do and see if there's an easy solution to it.
Make your binaries equal to each other.
No, not equal, because that one doesn't work.
Less than or equal.
Less than or equal. Now, in the last class, I wrote the 1 and then I wrote the 2. I don't know why, I did. But in that case, I had to make it greater than or equal. So, I mean, obviously those two things are saying the same thing, okay? So you can do whichever, whatever way you write it down, it's fine with me. But if a logical comparison operator will work, great. If it doesn't, then start thinking about things like add this up and make it less than, a constant. Okay, but this one worked. So let's see, this is what I usually do, because I'm trying to abbreviate as much as possible. If 2, then 1. And then I'm gonna put cells in here. And I'm saying this because on the test, you have to put this in such a way that the IAs can grade this and see what you did, okay? See what it was you were doing. And what I would be doing is a reference to the cell that has the binary variable for whether I'm using supplier 2, that's C19. So on one side of your inequality, you're putting C19, and you're saying that has to be less than or equal to the binary variable for 1, for supplier 1, which is in B19. And what you're doing is you're either saying that the C19 has to be less than the B19, or the B19 has to be greater than the C19. And obviously those are saying the exact same thing. So either one of those is fine. Here's something that can help you just a little bit. It's not a fail-safe, you've done it right. It's a way to pick out if you potentially have done it wrong, okay? So when you look at this, we're in violation of that rule right now, right? We're using 2 and we're not using 1. When you look at this, that should be a false statement, okay? When you first put it in. Now again, does that mean you did it right? No, it just means if you saw it and that wasn't a false statement, you would know you'd done it wrong, okay? So, that's at least a little trigger there to help you a little bit. Okay, so I put that one in, that has to go in Solver also. I go back into Solver, and I add this constraint that I just did, but I've notated it somewhere where, of course, the IAs will be able to find it to grade it, but whichever cell you put the first one in, less than or equal to, so I'm not saying cell references because you could put this anywhere, I don't know where you put it, but what you just notated here, put it into that constraint. You've now worked your way up to 7 constraints. We started with 5, then we added the new minimum. Now we're adding the, if you're gonna use supplier 2, you have to use supplier 1 thing. Okay, so we're now up to 7 constraints, and when we solve it, oh, I didn't ask, but I think we all knew that our costs were probably gonna go up, okay? Because we asked it to do something that the last optimal solution wasn't doing. And so therefore, if we're asking it to do something extra, then chances are the price is gonna go up, and in this case, the cost, is because it's a minimization problem. The objective got worse, okay? And what do we do now? We don't even use the same suppliers. We've said forget 2. We're not gonna use 2 if we have to use 1. So we use 3, 4, and 5, and we spend a little more money than we were before. And then they said, oh, by the way, if you use supplier 4, you cannot use supplier 5. Oh, great. Okay, so now, if we use 4, not 5. So I'm setting up my little area that will make it very clear what's happening. Okay. If you use 4, you cannot use 5. Actually, they don't say a thing about if you don't use 4. Apparently that doesn't really matter. But if you use 4, you cannot use 5, so therefore that one's not okay. Again, my mind would go first to, do I have a logical operator I could just put between them and it would work? Do I have a logical operator I could put between them that would work? No, and that's never really gonna happen when one of the, when those two are both still in there, that's not gonna happen, is it? Because there'd be no logical operator that would go in there that would work for that. Okay. Now my next move would be to think through doing what? What might we do next?
Some 4 and 5 and give us the equal to 1.
Yeah, just like, okay, we'll talk about that in a second, but sum them up, which would be, and then say this is less than or equal to 1, we allow these three to prevent that 1. This is just like the Tim and Joe hate each other. Okay, we might have said it differently, but the end result is the same. When we said it before, we didn't use the like, one following the other kind of thing. We just basically said, Tim and Joe hate each other, they both can't go. Boom, that leads to this. This time we said, if you use 4, you can't use 5. Okay, sounds different on one hand, but it's really not, because all it's preventing is the both of them happening thing, okay? They just both can't happen. It's the same result, same result. So, go in here and we add up the binary reference that's in E19 to the binary reference that's in F19. That's your one side of your inequality that you're making sure is less than or equal to 1. Okay. Again, did I do it right or not do it right? Well, I can't guarantee that I did it right, but I see this. I'm in violation of this rule right now. I'm using both 4 and 5. So when I look over here, that should be a false statement. Okay, so that's just me knowing a way to figure out perhaps that I might have done it wrong. If I didn't see a false statement there, I would see that. I need to go back into Solver, add my yet another constraint. So I add one more constraint, and I don't know which cell references you put in there, but go ahead and that's what you just set up, put it in as a constraint. This and as a constraint. I'm up to 8 constraints now. Worked my way from 5 up to 8 with my additional stuff that was on the PowerPoint. And what do you figure are going to happen to costs? We figure they're going to do what?
Go up.
That's what we figured. And we're right. They do go up again. Now we end up using 1 and 2, because we have to use both of them if we have to use 1, and then we're using 4. We can't use 5. Yeah. So anyway, it's starting to get complicated, but we have now reached this solution. All right, is anybody's model right now spinning endlessly and not coming up with a solution? Okay. Just do a cancel, just do your escape key and stop it.